In this video, we will solve problems from exercise 1.4. Question number 3. Graph the function f of x is equal to x cube and g of x is equal to cube root of x on the same coordinate plane. Find f composite function with g and graph it on the plane as well. Explain your results. So let's first take the function f of x, which is equal to x cube. So f of x is equal to x cube is our first function that we're going to work with. So if x is equal to 0, then your y is 0. So we say x and y 0 and 0. If x is 1, then y is 1. So you have 1 and 1. If x is 2, then y is 8. So 2 and 8. Similarly, when x is equal to minus 1, y will be equal to minus 1 also. So minus 1 and minus 1. And x is equal to minus 2, y will be minus 8. So minus 2 and minus 8. Now let's plot the points. So it's 0, 0. Then you have 1 and 1, minus 1 and minus 1. Then you have 2 and 8. And you have minus 2 and minus 8. So let's graph them. A graph will look something like this. Now let's graph the second function, which is g of x is equal to cube root of x. So g of x is equal to the cube root of x. So when x is equal to 0, now your y, which is the g of x, will be equal to 0. So here let's plot the points x and y, 0 and 0. Now when your x is equal to minus 1, your y, which is g of x, will also be equal to minus 1. And when your x is equal to 1, so minus 1 and minus 1. Y will be equal to also 1. So 1 and 1. When your x is equal to minus 8, then your y will be equal to minus 2. So minus 8 and minus 2. And when your x is equal to plus 8, your y will be equal to plus 2. 8 and 2. So now let's plot the points on the graph. Let's use a different color. So you have again the same points. These 3 points are the same. However, you have 8 and 2, and you have minus 8 and minus 2. Let's try and sketch this now. The graph should look something like this. Now let us see what happens when we do f composite with g. Of x is nothing but f of g of x, which will be equal to f of g of x's cube root of x. So f of cube root of x will be equal to cube root of x to the whole power 3 cube. So which is nothing but x. Therefore, you can say if this is equal to y, your y is equal to, therefore y is equal to x is the function. So if your x is 0, y is 0, 1, 1, 2, 2, 4, 4, 8, 8. Therefore your line would look something like this. So that's your f of x, sorry, f of g. So that's the function. So from the picture, from the graph rather, you can see that f of x and g of x are reflections of each other, and the reflection is in the line of symmetry which is f of g. So you can by inference you can say that f of g is the line of symmetry for the functions f of x and g of x which are reflections of each other. Right? Question number 4. Write the steps to obtain the graph of the function y is equal to 3 times x minus 1 the whole squared plus 5 from the graph y is equal to x squared. So what they want you to do is, from the graph y is equal to x squared, they are expecting you to derive this graph. So let me just give you a rough work of what's happening here. So let me just, this is our rough working. So you are given y is equal to x squared. Now, so this is your f of x is equal to x squared. Here you have x minus 1. So first you will do x minus 1, f of x minus 1. So f of x minus 1, this is x minus 1 the whole squared, because our function f of x is x squared. Now we have here 3 times x minus 1 the whole squared, so which means you need to find the function which has 3 times x minus 1 the whole squared. So before we go into that, let's just try and visualize what this curve is going to look like. So this will be when x is 0, y is 0, when x is 0, 1, y is 1, x is minus 1, y will be again plus 1, x is 2, y will be 4, x is 3, y will be 9. Similarly here it will be 4, minus 2 and 4, and minus 3 and 9. So this is just for your understanding. Now let's try and graph this. So what you will get is a parabola like this. Now when I say x minus 1, f of x minus 1, we know that the graph is going to shift to the right by 1 unit, which means this point will come here, this point will come here, and this will come here. So all will get shifted by 1 point to the right. So your new graph will look something like this. Pardon me again. So this is your y is equal to x minus 1 the whole squared, and this graph is your y is equal to x squared. Now if I say 3 times x minus, or rather if I say 3 times f of x minus 1, then that is equal to 3 times x minus 1 the whole squared. So this becomes our new function. So when you multiply a function with times 3, then what happens is it begins to shrink. It will begin to compress. So probably it will look like something like, not taking exact values, but I'm just saying that would look like, this is our new function, but here it will look compressed like this. Something like this, it will look compressed. So this is our new y is equal to 3 times x minus 1 the whole squared. And then you have to add 5. So when you say 3 times f of x minus 1 plus 5, then this curve will get shifted 5 points upward because it's plus 5. So 1, 2, 3, 4, 5. So it will go here and it'll get just shifted up here by 5 points. So that's our new curve. So just for your understanding, now let's try and put it in words. So for the exam point of view, we will write down the steps as is mentioned here. It says write the step. So now that we have a clear understanding, we know that first, step 1 would be to draw the curve y is equal to x squared. Then step 2, since it's shifted by 1 unit, you will, for y is equal to f of x minus 1, or in other words x minus 1 the whole squared, shift the curve 1 unit to the right. Then step 3, now you have to redraw a new curve using, because it's a compressed curve. So now draw the curve y is equal to 3 times x minus 1 the whole squared. Then step 4, to get y is equal to 3 times x minus 1 the whole squared, you can say for shift the curve y is equal to 3 times x minus 1 the whole squared by 5 units upward. You will get the, sorry, it should be plus 5 here. So to get this, you need to shift the curve by, this curve by 5 units upward, and you will get your final graph for y is equal to 3 times x minus 1 the whole squared plus 5. Question number 5. From the curve y is equal to sine x, graph the function. So this is your function y is equal to sine x. So you're asked to graph first y is equal to, first question, to graph y is equal to sine of minus x. This is nothing but minus f of minus x, right? So this would be a reflection. Therefore y is equal to sine minus x is a reflection of y is equal to sine x about the x axis. So the function would look something like this. So your function would be y is equal to sine minus x. So it's a reflection of y is equal to sine x about the axis, which is x. Question number 2. Y is equal to minus sine of minus x. So we need to graph this function. So this is your function y is equal to sine x. Now what happens if this is minus of sine minus x? So it's a inverse to the inverse, so which is, that is equal to, you can say that this is nothing but minus sine x, which is sine x. Therefore this function is the same as the given original function. So this is also minus sine of minus x. Question number 3. To graph y is equal to sine of pi by 2 plus x. So this, we can see that it's a function. You can call this as if f of x is equal to sine x, then our new function is nothing but, y is nothing but f of pi by 2 plus x. So what happens is automatically the entire graph gets shifted by pi by 2 to the left. So the graph of y is equal to pi by 2 plus x will get shifted to the left from the graph y is equal to sine x. You can call this as y is equal to sine pi by 2 plus x. So let's just try and sketch it by shifting it pi by 2 to the left. So that will be our graph, which is shifted pi by 2 to the left. So that is y is equal to sine pi by 2 plus x, and our original function is the blue curve, which is y is equal to sine x. We just have to also highlight the fact that for question number 3, the function sine pi by 2 plus x is also the cos x function. Right, now let's go to the last one, which is y is equal to sine pi by 2 minus x. So here I've sketched y is equal to sine x function. Now let us do some adjustments to this. If you put a minus in the front, then this will become sine x minus pi by 2. Okay, so, or in other words, let me make it more easier. Let's have this as sine of minus of pi by 2 minus x. We know that minus of minus will become plus. So let's take this minus inside, then this becomes sine minus of, put big brackets here, minus of, with small bracket, this will become x minus pi by 2. Now sine minus of this is nothing but minus of sine x minus pi by 2. So let's just take this function sine x minus pi by 2. So if this is your sine x function, sine x minus pi by 2 will shift this graph by pi by 2 to the right. So your graph will look like this. So let me graph it. This is your y is equal to sine of x minus pi by 2. But what we really need to get is minus sine of this graph. So when you say minus of this, that will be a mirror reflection of this graph on the x-axis. So that would look like, that's the exact reflection of this. So that's the new function is y is equal to sine pi by 2 minus x. You can also see this is exactly the cos x curve, which is also equal to the cos x curve. So therefore, we can say the function y is equal to sine pi by 2 minus x is also the y is equal to cos x curve.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.